The molar mass of a substance is the mass in grams of 1 mole of that substance. Recall that 1 mole contains 6.022 times 10 to the 23rd particles. And so the molar mass can also be defined as the mass in grams of 6.022 times 10 to the 23rd particles of a substance. The molar masses for several atoms are listed below. For hydrogen, it's 1.008. For carbon, it's 12.011. For nitrogen, it's 14.007. For oxygen, it's 15.999. And for sulfur, it's 32.06 grams per mole. Where do these numbers come from? We can look on the periodic table. And for hydrogen, notice that we have the atomic number at the top, which corresponds to the number of protons. The decimal number over here is equal to the atomic mass, 1.0080 AMU. That is the mass of 1 atom of hydrogen. However, the same number corresponds to the mass in grams of 1 mole of hydrogen. So we can say that this 1.0080 is equal to the mass in AMU of 1 atom. Or if we make the units grams per mole, we can say that 1 mole of hydrogen has a mass of 1.0080 grams. Another way of saying this is that the mass of 6.022 times 10 to the 23rd atoms of hydrogen has a mass of 1.0080 grams. The molar masses for all atoms are listed on the periodic table. So notice for carbon, carbon's molar mass is 12.011 grams per mole. Nitrogen's is 14.007 grams per mole. Oxygen's is 15.999 grams per mole. And sulfur's is 32.06 grams per mole. Those are listed here. What if we wanted to calculate the molar mass of a compound? The molar mass of a compound corresponds to the mass of 6.022 times 10 to the 23rd molecules or units of that compound. In order to calculate the molar mass of the compounds, we simply need to sum the molar masses for each individual atom comprising that compound. Consider water. Water has 2 hydrogens and 1 oxygen. And so the molar mass is going to equal 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. As we see here, the molar mass for hydrogen is 1.008. And so the molar mass for water is going to equal 2 times 1.008 plus 15.999. And the units are going to be in grams per mole. Recall that these two are for the hydrogens. And this 15.999 is for the singular oxygen. If we go into our calculator and plug this in, we get 2 times 1.008 plus 1 times 15.999 gives us 18.015 grams per mole. And so the mass of 1 mole of water is equal to 18.015 grams per mole. In other words, 6.022 times 10 to the 23rd molecules of water has a total mass of 18.015 grams per mole. Let's do another example. Sulfur dioxide has the formula SO2. And so it consists of 1 atom of sulfur bound to 2 atoms of oxygen. Up here, we see that the mass of 1 atom of sulfur is 32.06. And so the molar mass of sulfur or sulfur dioxide is equal to 32.06 plus 2 times 15.999. Once again, 32.06 corresponds to our singular sulfur. And here, this 2 times 15.999 corresponds to the mass of 2 equivalents of oxygen. And if we plug this into our calculator, we get a molar mass of 32.06 plus 15.999 times 2 equals 64.058 grams per mole. And so 1 mole of sulfur dioxide has a mass of 64.058 grams. In other words, 6.022 times 10 to the 23rd molecules of sulfur dioxide has a mass of 64.058 grams. Finally, for the mass of sulfuric acid, which has a formula H2SO4, we need to add the masses of 2 equivalents of hydrogen, 1 equivalent of sulfur, and 4 equivalents of oxygen. This gives us 2 times 1.008 plus 32.06 plus 4 times 15.999. Just ran out of room there. We can just plug this into our calculator. And we have 2 times 1.008 plus 32.06 plus 4 times 15.999. And this gives us a molar mass of 98.072 grams per mole for sulfuric acid. 98.072 grams per mole. Recall that this 2 times 1.008 is the mass of the 2 hydrogens. 32.06 is the mass of that 1 equivalent of sulfur. And the 4 times 15.999 is the mass of the 4 oxygen atoms, which total sums to 98.072 grams per mole. And so 6.022 times 10 to the 23rd molecules of sulfuric acid has a mass of 98.072 grams.